In this video, the third in the series, we are looking at this Hello World program and in assembly in this simple sort of 8-bit architecture. And we had gone through the first iteration of the loop. So we were down at in the loop section of the assembly program, and we had just sort of completed the J and Z, the jump if not statement opcode. And the condition was false, as you see in red in the Z flag. And so we jumped back up to the label of loop, and we're beginning our second iteration. And it's going to be very repetitive, of course, as loops are, until we sort of get till we've displayed the exclamation point, the last character in the string, and we're now pointing to the 00 that follows the 21. So we had up there in the first row, you can sort of see slightly under my red arrow there, the 21, that was the exclamation point. And then the part that you can't see is the string termination character, the 00. So we're going to imagine we've finished the iteration with the exclamation point, and now we're at the 00. And so we're going to pick up back up in sort of that loop. Okay. So now we've incremented C, and we've incremented D, and now we are at the compare. So we've just put in the, when we did the move square bracket DA, we put the exclamation point into a location of the memory map location, and we see it up there in the output. We increment C, so we're pointing at the string termination character 00. We've incremented D, so in case we were to put something after the exclamation point, we won't be, but we're set up if we were. And now we are comparing what's in register B, which is 0, to what's pointed to by register C, which is that string termination character, also 0. And this time when we do the comparison, we're going to get true. So right now, this is the before. So we're getting ready to make that comparison. So the Z is false, but after this comparison, we're going to move to true. So we make the comparison. We're comparing what's in B, 0, to the string termination character 0, and we have Z is now true, and then we, as normal, do our instruction pointer move to the next thing, which was the 27, which is the jump if not. Okay. So now we're ready to do the jump if not. We have the instruction 27, jump if not, and then where we are jumping to if it's not, which is the 1F, which is the loop. But in this time we won't be jumping, so we'll be moving outside of the loop. So we will be sort of more incrementing rather than jumping back. So we look, the instruction tells us to look at the Z flag. The Z flag is true, so we will not be going to the label. We will instead be moving, we will be incrementing, moving the instruction pointer to the next instruction. So this is before, so right now we're pointing to the 27, but we just did a normal, not a step back to the label, but just a normal increment of the instruction pointer. And so now we're pointing at the next instruction, the 36. The 36 is a pop. Remember, previously we pushed, where was it? In the beginning of print, we pushed A and pushed B. So now we are now popping them. So we had this was sort of boring. We had zeros in A and B, but we can imagine them being something more interesting than that. And now we are sort of returning the state of our registers to what they were before we came to this subroutine. So we're sort of getting ready to leave the subroutine. So we are popping. So we're going down to the stack. Pop is a stack action. So we're going to be dealing with the stack. We're going to take that. We see down there in the stack, the darker 00 is just the next part of, that's not what's on the stack, that's the next available spot of the stack. Then we see the first light 00, that's that B value that we stored, that's what's at the top of the stack right now. Then we see that A, then we see the 17. Okay, so it says pop B, so we're going to take the 0 at the top of the stack, we're going to put it in B. It already has a 0, so it's going to look like maybe nothing happened. But so this is before the pop. So we have we're pointing at the top of the stack is not the darker 00, but of yellow, orange 00, but the first sort of light one going from left to right. And that's going to be put into the register B. And now we move, so that's what happened. So we popped the value, we put it in B, we changed the stack pointer, so we've once you pop something, then it's no longer available, and you move the stack pointer. So the stack pointer is now the first available thing is the light color. The dark 00 is now not available. It's just the location if we were pushing, but we are going to be popping. So the light 00 is what's the value at the top of the stack, and that's what we will deal with next. And so we're changing the instruction pointer, we're changing the stack pointer, we're putting a value into register B. Now we're getting ready to pop A. So we're going to, so the 36 is pop, the 00 refers to register A. We're going to take the value that is at the top of the stack, which is again a 0. We're going to put it into register A. Register A is a 21. We're going to overwrite it with the 00, the original value of register A. And then we will change the stack pointer and we will change the instruction pointer. Okay, so now we are pointing to, so we finished the pop. We wrote the 00 over the 21. We adjusted the stack pointer and the instruction pointer, and we're done that instruction. So we're pointing now, the instruction pointer is now pointing to the return instruction. So the return instruction just says go back. So as an instruction, it has no data. But a return instruction gets its data from the stack, so that so it doesn't need the instruction doesn't need data, but the execution of the instruction needs data, and that data is on the stack. That's that 17 sitting there. So we are doing the opposite of our call. The return undoes the call. The call put that 17 on the stack. Now we're going to take that 17 off of the stack. Okay, so now we've executed our return, and that changed that moved the stack pointer, that changed the instruction pointer. The instruction pointer now has a 17, and that is pointing to our halt instruction. So the call, when we said call print, that put a 17. The 17 was where the halt was. Now, when we returned to that 17, to the halt. So now that's what happens after the return. And that 17 is that value may be still there in memory, but it's not really on the stack because that value is the first place, not that we can get anything off the stack, but the first place that we would write if we put something on the stack. So that 17 isn't like not accessible. Now we're at the halt command, and zeros have played different roles along the way, but if 0 is the opcode, if it's the action, then it means do nothing. So we're getting ready to do nothing. And so we do nothing. We know this is to stop. And if we had a more sophisticated machine, this would be like return control at the end of the program, return the control to like the operating system or something like that. But for this very simple architecture, it just means stop, don't do anything more. So I could keep hitting, like if I were running it, keep hitting step and nothing would happen. My action is halt. My action is to do nothing. So I do nothing. And that is the end of that. Thanks for your attention.